So first of all, obviously you guys can tell that we're using a different service to do our note taking now. We're going to test out IOXA here. The link was shared in the Slack for the notes, the note document. If you have issues signing in, signing up like that, just forward them on and we'll get them to the developers somehow. Um, just a quick thing. We talked last week, we're going to be doing an after coding session today. So if you guys want to stick around after the meeting, we'll just go through and code away at whatever we want to. We'll just all be here together coding. Probably going through some PRs, doing some other things, just chatting. That'll be after the meeting once we're done. With that, we can move on to some of the quick reports. I see Devin got himself listed first there, so take it away, Devin.
Sure. Yeah, so it looks like we're just trying to finalize where we want to house some of the nitty-gritty theory details that some of the stuff we do is built off of. So we just need to finish that up. We have the content, just put it somewhere. I've created a good test example for FDEM development. So that's both the rings that you get when you do EM inversion and some of the tiling stuff that Dom has been working on. And working on finalizing and publishing these code validations. So I compared SimPEG with analytic solutions and other coding packages, and I'd like to make that available to people. So that's sort of what I've been working on. And I'll give a quick update for Soggy because he can't be here today. He said that he's made the pull request to bring in EM1D to SimPEG. So yeah, I'm gonna maybe poke around that today. And hopefully very soon we'll have all the EM1D stuff in SimPEG as opposed to its own repo.
So I did a quick look through earlier. I guess it seems like it's just like almost like a copy paste of EM1D into a separate module in SimPEG.
Yeah, that's basically what I thought it was. I mean, the whole point was we were going to go and restructure it and make it SimPEG-like within its own repository so that we could just kind of copy and paste it into SimPEG.
Okay. I guess I was kind of more expecting it to be more like synthesized within SimPEG almost. If that makes sense. Because it's like at this point, it's like it seems like it's just, oh yeah, this is something else that's just lives inside a separate module. Like it still doesn't feel as connected as it could, if that makes sense.
Yeah, I think there's still work to be done on making it fit with our class structure and kind of ironing out those details. But I think it's a good time to bring it in anyway. Otherwise, you're just fine tuning it over there and not really seeing how it fits with the package it wants to end up in. So, well, there's a PR for it. We still have some work to do. But that's basically it.
But is the PR straight for master, or would it be for a SimPEG 1D branch on SimPEG?
It's a master branch.
Yeah.
Yeah, so we'd like to finalize it and bring it in and release it. Yeah, really useful tools that I think a lot of people want to use, and we should prioritize it.
I guess my concern is like there's probably a decent amount of things that look, or at least things that look like they would have been reproduced by, that are reproduced that come from like GeoAnna. There's a bunch of analytic functions in there that should probably just either be imported from GeoAnna or just not necessarily imported at all.
Yeah, well, I mean, one thing that I want to go through is take that pull request, make a list of remaining items, big items that we want to complete, and then actually have a game plan for it. So right now we want to see if it would actually run, and it seems like it's doing a pretty good job except for the VRM problem. But yeah, there's some remaining tasks, so we just need to make a list and then go through them.
Do you imagine that it's I guess in my opinion, it seems like the structure of it might change around a little bit as well as we're doing, like getting it more in line with the SimPEG class structure. And I would hesitate bringing it into master until we finalize on sort of a structure.
Yeah, I completely agree. Yeah.
Okay. Sounds good. So I see Don coming up next. I've seen you post a few things on Slack over the week. So
Yeah, continuing the expanding the desk simulation, testing on the frequency domain, 3D frequency domain. And the speed up is quite amazing. It's almost like a 10x speed up over the current implementation. And really, the major speed up is not really the tiling right now, is just to be able to use J during the inversion instead of having to do all the matrix in factorization over and over again, right? And that saves us a ton of time. So it's super promising. I'm quite happy. And then I work with Devon looking at examples, and then Sug helped out on the just making sure the derivatives were all done right, and it looks pretty good. So yeah, just moving on. That's it.
have you done any sort of tests on accuracy?
It's exactly the same. I mean, I've been done formal ones, but I tested the two vectors, right? I did the not stored J versus doing the usual way. And then the two vectors are identical, right? There's no reason why they shouldn't be, because all we're doing basically is one JVec and then sending this, well, not the vector, but just JVec call and then sending it to Zara, right? So it's the exact same mechanics. We're just storing it instead of keeping only the factorization.
I guess I was kind of more so curious about the accuracy as far as the tiling part of it, breaking it up like that.
No, so that's a good point. Right now, I only did tiling in frequency, so I was basically splitting. We have in this example, we have 3 frequencies, right? So I'm basically creating 3 simulations, and the 3 frequencies are run in parallel on the same mesh. So it's not even an issue for this because they all have the same mesh.
Okay.
And which is a nice part with the way it's implemented, is that we can split spatially or in frequency as well, or both at the same time, right? So yeah, once we get to the tiling spatial, then we'll have to worry about this. But if you don't tile spatially, then it's the same. It's the exact same, right? Yeah, just saving time because we run stuff in parallel, basically.
Mm-hmm. Sounds good. John, I see you up next on the list.
Yeah, just still picking away at the MTPR. Almost there. Just got that a joint left on the 1D, and then I think all that should be passing. I haven't tested all the frequency domain tests yet, or the FDM stuff, but I don't know if we changed much in there, but I'll go through and check for sure in there. And then that should be wrapped up. And then, yeah, I'm just playing around with the DC tiling, just looking to improve the weights, and because it seems like, yeah, when you're outside of the domain, the big cells they're going to 0, so they're not holding the background value. And yeah, so if we apply the sensitivity depth weights a little bit differently, we should be able to solve that. And yeah, that's about all I'm picking away at.
Cool. Shalom. I see you made a nice research branch.
Yes, I just create a new repository in the SimPEG research. Yeah, that's all what I did in the last week.
What are you hosting there?
Oh, sorry.
What were you? Is it a paper you published or working on?
Oh, yeah, that's the paper Dr. Sun and me published in the geophysical prospect. Yeah, I just upload the repository and upload the code used for this manuscript.
Okay. You want to give a quick 10-second pitch of what your paper was over?
The also
What's your title?
What's your title?
And just read the title. The title is pretty informative. Just read the title.
So the title of the paper is recovering the sparse models in the 3D potential field inversions without bound dependence of the staircasing problems using a mixed LP norm regularization.
Cool.
Yeah,
It's exciting. I'm looking forward to.
There you go. We know what it is. Good title.
Yeah.
We
Tom is
are
a reviewer.
we're taking Dom's awesome mixed LP norm inversion and are abusing it to in every way we can.
That's great. Torture it.
We're trying to break it.
Good. Okay. Let's see. Next on the list is Soggy that already talked about. Dieter. See you on the list next year.
Yes, I just pushed out a new version of EMG3D with arbitrary shaped sources and kind of magnetic dipoles. This is not anything, it was possible before, but you had to manually write your cell, adding those source elements to your source field to model it, and now it's kind of neatly in functions implemented. It's just at the moment the gradient that I have in the simulation class can only handle electric receivers, and that should move soon to handle electric and magnetic receivers, and that's kind of the first thing, because then for the adjoint I need magnetic sources for the back propagation. Yeah. Other than that, I think I mentioned last time that I have this automatic meshing that I can throw any model at it and survey, and then it does the gridding internally. And of course it was abused, so I had to make all the estimation of the parameters much more conservative, which leads potentially to bigger meshes. But it's the danger of automatic things that the users can just input something that you didn't anticipate, and then it turned out that the computation mesh was way too small and the receivers are always placed at the edge of the mesh, and then it was wrong, and then it says EMG3D is wrong. And I said, well, yeah, in a way, yes, I have to make it more conservative. But I think that's a general thing. The easier you make to use, the more it's getting abused. But that's it, not much. Getting back in, as I said, Lindsay, with our paper correction. I thought it's going to be a nice start, January, and then you come back and bam, and your agenda is full and no time. And yeah, anyway.
So Dieter, is your source completely arbitrary? In other words, could you imagine an underground environment where you've got some tunnels and you're just trying to string an inductive loop, through various tunnels and crevices and make a kind of a crazy loop? Is that
in theory, I was actually wondering how does SimPEG generate the source vectors? You gave me once an example, Lindsay, but I think you create the vector, right? So how it does now, if you give it points, you give it 2 points, it looks in which cell these are, and then it does an adjoint interpolation. It propagates this point to the edges. And then if you do an arbitrary shaped source, you just give all the edges. Everywhere there is a kink, you give these XYZ points. And then it just places all these cells that are affected and distributes the energy to the edges that are next to it. If you make a perfect loop with 4 elements or more, then you have a 0 moment and you have basically a magnetic source. And if it's just somehow shaped, it's an electric source. Yeah, but it works. It should work. I haven't tested extensively, but it should work in any way.
Okay.
And I hope it should also work for magnetotellurics, actually, if I put in a layer of random sources somewhere high up in the sky, it should work, but I have never tried it, in theory.
That's sort of what we're missing, right, for a SimPEG right now. If we want to, be able to go beyond E3D, basically, it's arbitrary sources. Correct? We can't do it right now.
Yeah, I think the list of, I was looking at it the other day, the list of EM source classes for at least the 3D FEM problem, I would say is not complete. That would actually be something useful.
Do you think we could call your library here to just get at least the source terms? If we use your functions to put it on a Nocture or tensor, you think we could cross talk like that for that?
Yes, and when I use SimPEG and EMG3 for the comparisons, I can create a vector with EMG3D and put it into SimPEG or vice versa, that they are the same. But I can only create source fields for tensor meshes, because that's all EMG3D can do, right? But then I don't think I mean, if you have one dipole, if you can create a finite length dipole, it's just a matter of looping over all the segments and adding them up.
Yeah, exactly. And we don't have that class yet. We don't have the arbitrary line segment, and that would be really useful, especially for an IO with and interacting with GIF codes.
There is a PR that has the line segment implemented for finite or frequency domain. It's
okay.
Still been getting.
Joe helped me write that last year, and I used that a lot for my thesis stuff.
Yeah.
Yeah. Okay. I mean, I've got an example that I can test it out against an analytic right now. So I could go on that branch and see if we're happy with it.
When I was using it, I was doing I did a lot of testing before I used it with different analytic expressions. I haven't tested it in the last few months, so I don't know if anything's changed with it, but it was working well.
So then, is the holdup just that we haven't, what's stopped it from getting pulled in?
Well, actually, there's some random test on it that keeps causing it to fail, and I'm not sure why. It's nothing to do with the line source. It's just some weird memory glitch, and I still haven't been able to isolate it. That's the only reason. Okay, so then I see Lindsay on here next.
Yeah, I don't have too much. I feel like I resonate with Dieter's statement that I thought January would be calm. That's not the case. But I did put some of Sean Walker's comments. He sent a thoughtful email after watching some of the governance discussion. And so he compiled some just thoughtful comments, and I asked if he was okay with me posting that in our governance doc. So I've added that at the bottom. So if folks want to just take a look, I think he's posed some good questions for us to kind of think through. So yeah, we can maybe think about kind of resurfacing that conversation in the near future.
As far as me, I've been working more on implementing the boundary condition matrices that are in some of the theory section, just kind of getting them generalized for some of those other weak forms for the ones that are not. Working on those. For generally, my goal for that is to be able to implement the Robin boundary conditions on all of them. So it's just one thing that we have to call for, any mix of Neumann, Dirichlet, or Robin that can all be made with the one call. It's also, again, January is picking up really fast. I got been working on reviews for a paper I got back at the beginning of the year, which is exciting. Other than that, not much stuff has happened in the past week. Just meeting with people and putting stuff on my plate for later. with that, is there anyone who wasn't able to add to the note document yet that would like to discuss a little bit or update us a little bit?
Speaking of torturing code, you guys watched you watched the DCIP from Discovery yesterday?
No. What was it?
Dear Lord.
Dear Lord.
Was there anything that was, I turned it on just for a couple of minutes and I thought, I don't quite have time for this, but was there anything that was really kind of came out of that, Dom, that was important or interesting?
No, I mean, other than the obvious that you know, if you carpet your surface with more, you know, distributed sources receiver, you get more sensitivities. But then he didn't like the results that DCIP 3D was giving him, so he started cranking down the chi factor, and then starting to get a ton of garbage, and it was just showing slices over slices of like models that are totally overfitting the data without giving any explanation about anything. It was painful.
Was that Discovery or the Quantec talk you're talking about?
The Quantec talk? Yeah, was it Discovery giving a talk too?
No, oh, I thought you said Discovery. That's why I was like, I was not.
Sorry, no, Quantec, yeah.
Sure. Okay.
Oh, so it was sort of negative commentary about DCIP 3D?
No, they just clearly don't know what they're doing. You know, they're just using the inversion and torturing the heck out of it with a synthetic example and trying to make sense of, you know, garbage sensitivity, garbage coming from like overfitting the data basically, and then
so maybe this is another group that would benefit from an open source course for the fundamentals of inversion.
Yes, 100%. Hopefully they want to pay for it.
Cool. Okay then. With that, I don't see anyone else. I don't have any other topics that I think we've brought up. So we will continue this with some coding after. Meanwhile, I'll stop recording. So goodbye.
Thanks, Joe. Nice seeing everybody.